Wrestling, as most sports are, is a combination of the laws of physics. In our project, we will demonstrate and discuss the use of pure momentum in a wrestling move called the fireman's carry. The equation for pure momentum is P equals m times v, where momentum equals mass times velocity.
So to find Matt's momentum as he hit the ground, we must multiply his total weight by his total velocity. We know his weight is 70.5 kilograms, but we must find his velocity using the formula v equals d over t. Velocity equals distance over time. By measuring the distance of Natalie's knee to where Matt's shoulder landed, we found he went a distance of 0.9 meters in the span of 0.7 seconds.
After plugging these measurements into the velocity formula, velocity equals distance over time, we found that Matt's velocity was 0.63 meters per second. By plugging this into the original momentum formula, momentum equals mass times velocity, we found that Matt's momentum was 44.415 kilograms by meters per second.
Now to compare Kamal's momentum, we will go through the same calculations. We know her mass is 48.18 kilograms, so now we must find her velocity using velocity equals d over t. The distance from Natalie's knee to when Kamal's shoulder landed was 1.02 meters, and the time it took was 0.805 seconds.
When we plug these values into the velocity equation, we find Kamal's velocity was 1.267 meters per second. So now that we have our velocity and our mass, we can plug it into the original momentum equation, P equals m times v, to find her momentum, which turned out to be 56.273 kilograms by meters per second. According to these results, Kamal's momentum was greater than Matt's. This is because her velocity to mass ratio was greater, so she was traveling fast enough to generate a greater amount of pure momentum.